right, good morning. Thank you for joining me. Obviously, we're strapped in for a bit of a fun session today. This is going to be a bit of a session to do with Wi-Fi fundamentals, just some basic fundamentals, some planning, bit of a look around Ekahau design, the Ekahau Pro software that Wavelink as a distributor use, and we utilize to do correct and best practice planning as well. Then we're also going to jump in and have a little bit of a play with my FortiGate, do some basic configuration of a basic SSID profile, etc., connect the client. Then we'll set up some other configuration around VLAN assignment with different IP addressing, and then we'll jump into FortiLAN Cloud as well. I know a lot of people potentially haven't seen FortiLAN Cloud and its capabilities, and over the last few years, it has come a hell of a long way. So hopefully today's session will be a bit of fun and some good learning for those that may not have experienced or have some experience with the FortiGate, but may not have utilized FortiWiFi itself as well. Yeah, hopefully everyone gets a fair bit out of it. So that aside, those that don't know who I am Nathan Gibb. I am Wavelink's Channel Enablement Manager and National Pre-Sales Engineer as well. So I wear a couple of different hats within the organization. I run obviously sessions like this around Wi-Fi enablement and training. I also do training for our SpectraLink Wi-Fi and DECT handsets, as well as end user training, partner training, etc. And then pre-sales, especially around the Fortinet Wi-Fi. So I'm Ekahau certified, both in design and troubleshooting. I've been designing Wi-Fi networks for well over 10 years, with probably close to 1,000 designs under my belt as well. And yeah, I've been around the traps to sort of capture some of the knowledge that people would want to know in the industry. Oh, sorry, when planning a Wi-Fi network. So again, as I said, we're going to have a look over some Wi-Fi planning and design best practices. Again, we'll jump into Ekahau as a bit of an interactive session as well. So those that haven't seen what Ekahau can do, we'll have a bit of a look at that and hopefully have a good breakdown through that as well. Then a bit of a configuration demo on the FortiGate, and then, as I said, FortiLAN Cloud as well. I've created a nice big cursor for everyone, so hopefully you can see what I'm pointing at. I will be diving into some pretty detailed breakdowns of information. So I created a nice big cursor so everyone could see hopefully what I'm pointing at and trying to divulge that information for you as well. So with that, let's get cracking. So Wi-Fi as a medium, obviously we're into the 6th generation at the moment. And where has it come from? Where are we going to? Obviously, again, Wi-Fi 6, for proper Wi-Fi nerds like me, I of course still use the actual proper naming standards, so 802.11ac, AX, etc., where obviously they've created easy to digest naming standards these days with Wi-Fi 6, Wi-Fi 5, and then obviously the legacy standards as well. So you don't need to digest all of this information. This is just a quick snapshot to let everyone understand, you know, where we came from in terms of the legacy and its capabilities, and where we're going to and beyond going forward as well. So back in '97, you know, we had 802.11 capabilities, very slow Wi-Fi, but Wi-Fi nonetheless. Data rates of 2 megabits per second, theoretical max at the time. And 802.11b came in, blew it out of the water with 11 megabits per second. That's obviously on 2.4 gigahertz frequency as well. 802.11a came in after that on the 5 gigahertz frequency, 54 megabits per second capabilities. Obviously, if you had a 5 gig chipset, and then of course, fast forwarding to 2019 and beyond, going into 2022 with Wi-Fi 6E coming through into the market as well. We're looking at obviously 802.11ax or Wi-Fi 6 and blisteringly fast speed. Again, theoretical maximums to actually achieve those speeds is quite tricky, and you need amazing conditions to do that as well, because obviously any magnetic interference will hinder those potential speeds as well. Also comes down to the modulation methods that are being used and a heap of other little interesting bits and pieces. But a bit of a recap on the capabilities as well of the technology. So 2.4 gigahertz band, again, being quite the legacy band itself. With the advent of Wi-Fi 6, we will actually see another rejuvenation, I suppose you would say, in terms of the capabilities of the 2.4 gigahertz band. And in that case, we're really looking at the capabilities, especially around IoT devices, so the Internet of Things. So anything that isn't a standard consumer or user device, being able to connect to the Wi-Fi network and just transmit very simple and short, sharp packets of information. That being said, however, those that don't know, we have quite limited capabilities with 2.4 gigahertz. Effectively, there are 14 channels, 13 are usable in Australia, but I say that with a big asterisk and a caveat on the side of it. The channels themselves are, most of them, overlapping. So we effectively only actually have 3 usable channels. Again, this might be common knowledge for a lot of you. Some might be a refresher, others you may not even know it. But that being said, 2.4 gigahertz can fall over quite rapidly based on purely the fact that we have so few channels to actually utilize. So what are those channels? There's channels 1, 6, and 11. They are the only non-overlapping channels within the 2.4 gigahertz spectrum, and should, I say should, but of course that's it's not usually how it goes. They are the ones that should only ever be used. As we can see here, a bit more of a breakdown, and I threw this slide in today just to give you a better understanding and a bit of a breakdown of Bluetooth beaconing, Zigbee BLE beaconing as well, and where that can fit across the spectrum as well. That in itself, those transmissions of signal are very, very small. They're literally short, sharp bursts of information to keep connectivity working, and it will work across the spectrum and find a free space to transmit as well. But in general, Wi-Fi terms, when we're designing, configuring and deploying a Wi-Fi network and still utilizing the 2.4 gigahertz band, we should always only be using channels 1, 6, and 11. I'm just going to quickly bring up Ekahau. So this is the spectrum analyzer that's built into Ekahau, and I've got my Ekahau sidekick with me as well. This actually gives you a really great snapshot of exactly what's floating in the air right now. And what did I just say before? The only channels that should be used, 1, 6, and 11. What do we got here? We've got an access point on channel 7. We've got one on channel 13, another on 13. Oh, Jesus. We've got one that's doing channel bonding on channel 5 across the 40 megahertz channel bonding as well. So that being said, that is showing exactly misuse of the spectrum and the channel assignment. Now, that in itself, what was that, Telstra router? Yeah, they're commonly configured out of the factory to be real pains in the butt, and put on channels that you just shouldn't utilize. So even for your home environment or work environment, it can be useful to find even simple tools. So I use Android handsets as a simple application on there that you can download, Wi-Fi Analyzer. There's plenty of other free ones as well. Also on the Apple App Store that you can utilize and actually fire up and just see which of those 3 channels is the most free and available for you to come in and potentially configure your office router or Wi-Fi equipment, or even your home router as well. So I'm hosting this session today from my home office, and obviously I've got this amazing tool, but I also just used my simple free tool to scan around, see where my neighbors are sitting, and then I've actually chosen channel 1 as my channel for my 2.4 gigahertz to utilize that. Also, you might be looking at this going, what the hell is going on with all this signal floating around? That is Wi-Fi transmissions in the air right now in real time. Again, looking at this on a proper spectrum analyzer, very, very cool stuff. and quite cool capabilities as well. 5 gig, yeah, there's a bit more transmitting on there as well. And I think I'm being the noxious one at the moment doing some channel bonding. And by the looks of it, I've got some other APs that are also actually potentially impacting my network. So looking at that now, I could then go, okay, well, I probably need to change my channeling to somewhere up the other end of the spectrum where it's a bit more free and easy to use. So that leads us on to 5 gigahertz. So the other frequency, mind you, and noted there is Wi-Fi 6E on the way and being ratified at the moment. So that is working across the 6 gigahertz spectrum. I didn't actually put in the channel breakdown for that, just purely for the fact that you can't really get any devices at the moment, and the regulatory domain still hasn't been decided for Australia in terms of which channel assignments are going to be allowed. So back onto 5 gigahertz though, as you can see here, we have a hell of a lot more channels. So effectively 25 in total, and they're 20 megahertz wide channels. Back to 2.4, we have effectively only 3 that could be used that are non-overlapping and not going to cause interference and co-channel interference, etc., additional noise. So 3 channels compared to 25. Now 25 with the caveat of, again, back in your regulatory domain. Australia, the ACMA, we allow 22 channels, so we cannot actually utilize channels 120, 124, and 128. And actually, if I pop back to my spectrum analyzer, what are we missing here? Bang, channels 120, 124, and 128. As you can see, they are not available to be used in Australia. So when you're setting up your devices, you have to make sure that you are configuring them for use in that correct regulatory domain as well. Obviously, if you configured it to be US configuration, well, it's going to potentially open up those channels, but again, it's not allowed in our regulatory domain. So having a look at that though, even just a simple comparison, 22 channels compared to 3 is a hell of a lot more capability with the 5 gigahertz spectrum. Why is that useful, especially when it comes to planning and best practice? Well, if we've only got 3 usable channels, well, as soon as you've got more than 3 access points on 2.4 gigahertz, they're going to start impacting each other. And when we jump into Ekahau in terms of looking at the signal strength and capability of the access points and the signal propagation, it'll show you, and I'll highlight the fact that the access points themselves, obviously once they hit past that threshold, even if they were 100 meters away from each other on the same channel, so again, if we pop back up to 2.4 gigahertz, channel 1 is a great example. If we had 2 access points on channel 1, 100 meters away from each other, even with walls and other things in between each other, there is a very strong possibility that those 2 access points, or then the radio chipsets in the AP, the 2.4 gigahertz radios, will hear each other at the lowest transmit rates, or the lowest RSSI value, or dBm, decibel over milliwatt. What do I mean? Why is that important? Well, if they can hear each other, they can then start to cause problems with each other. So again, 3 usable channels, 22 usable channels in Australia. So when we're looking at a high density solution, office environments are fine until you start looking at multi-tenancy, shared office environment, multi-story, etc. Then it starts to become a problem as well. But when you're doing planning and design for a network, obviously utilizing 5 gigahertz more can give you far better capabilities, because we have more free channels, free airtime, faster speed capabilities, especially when we start to also then look at channel bonding. Channel bonding is effectively taking 2 of the channels, bonding them together to effectively create a 40 megahertz, an 80 megahertz, or a 160 megahertz wide channel. So that in itself, though, can of course also then cause more problems. Because again, if we had, let's say we had 8 access points, well, we can do channel bonding to an extent, but as you can see, we're still then utilizing more channels, or we're bonding them together. And as soon as you add more access points, you can then start to cause more noise and interference. So with large deployments, anything past the 22 APs, half that I would say, I would never utilize channel bonding. The reward in terms of that additional bandwidth is usually outweighed by the potential problems that it might cause. I would rather have 20 megahertz wide channels and have the devices connect at a fast data rate and share the bandwidth in a more efficient way with the clients on the network, than try and give them a faster pipe but less capability of using it. So channel bonding, yes, very cool in what it can do, but to be used sparingly and always assessed on its merits for the customer solution that this is being put into as well. Simple analysis of and breakdown, 2.4 gig versus 5 gig. Why can you get further on 2.4 than 5 gig? Well, simple maths and physics. More cycles per second on 5 gigahertz. Of course, we're basically doubling the cycles per second on the sine wave, and of course, the 2.4 gigahertz frequency is a longer sine wave, therefore it will achieve longer distances as well. When trying to utilize, though, if it was a 5 gig, let's say 802.11a backhaul point-to-point link, you're still probably going to use 5 gigahertz, but then with a very high gain directional antenna to utilize that as well. And I've got a little note there as well, up to 50 users per radio for best effort. The sticker and data sheets on any vendor, not pointing fingers at anyone because everyone does it, they all state that most of the access points these days will facilitate, 512 clients. Geez, I think some of them these days are saying 1,024 clients. I would love to see that work in the real world, not in a lab. But more importantly, you've got to think of bandwidth division when it comes to that as well. If you're trying to cram 512 users onto an access point, they're going to have a pretty bad experience, and it's going to come back to bite as well. So utilizing a good rule of thumb that's always worked for me when it comes to planning 50 users per radio per AP. That being said, obviously that's looking at 2.4 and 5 gigahertz, or unless you've got dual 5 gigahertz radios in your access points as well, which of course there's quite a few in the market, and of course Fortinet definitely have as well. This is a cool little breakdown. As I was saying before, channel bonding, useful. I'm doing it at home. I'm being obnoxious, no stress there. Want some extra bandwidth. I'm not really impacting my neighbors. As we can see, I can come in here and I can actually look and see, right, at the moment, actually someone is potentially transmitting on the same channels. However, also look at the fact that that's at neg 90 dB. So the impact on my network is going to be very, very small anyway. But even just looking at this, I could come in and go, okay, cool. Well, up here, we're free to go nuts. So why don't I do 80 meg wide channel bonding or 160 meg wide channel bonding? Again, it comes at a cost. So as we can see here, this is a great, very simple breakdown. I'm going to go into a detailed one in a second. A breakdown of, as I put there, fact versus sales fiction. And again, I'm not pointing fingers, but everyone does it in the terms of selling their APs for their capabilities of 160 megahertz channel bonding on MIMO, 4x4 MIMO, 8x8 MIMO now, with some of the crazy beastly access points are coming out as well. But then the actual breakdown to achieve those theoretical maximum speeds. So again, the sticker on the box says, and the customer will point this out and go, oh, you sold me an access point and it said it was supposed to do 3.46 gigabit per second. Why? I'm only getting 1 gigabit per second, which if you're getting a gigabit per second on Wi-Fi, hot damn, I'd be bloody happy with that. But this gives you a really simple breakdown and a way to understand the limitations and requirements for Wi-Fi to achieve those theoretical maximums. And this itself is a great way to be able to speak with a customer and go, well, unless your device itself is 4x4 MIMO, your access points are 4x4 MIMO, and we're doing 160 megahertz wide channel bonding, then there's also absolutely zero, complete, no other interference on the spectrum, the radio waves in the air. You may hit that golden number of 3.4 gigabit per second. Oh, but also, what's the link speed on your switch port? If it's a 1 gig switch port, well, where's your bottleneck? It's not the access point, it's the switch port. And of course, we have multi-gig switches these days as well. So you can facilitate faster throughput on the top tier high density access points. But again, we need to make sure that we have, 10 gig Cat6A, we have 5 gig switch ports, we have 10 gig fiber uplinks from the distribution layer or the access layer to the disti to the core, and then a very, very fast internet connection to facilitate lightning speeds as well. So this, I love this. It's just a simple breakdown to cut through some of the fluff and the marketing and show you real world breakdown of, okay, cool. If your customer wants to achieve 600 megabits per second, well, again, if they can, fantastic. If they can't, well, they potentially, the client devices that they have, like our laptops and phones, they might just be a 2x2 MIMO device. And you're doing 40 meg wide and they're only hitting 300. Again, bandwidth division for the clients as well, take that into consideration. So, or it's a case of, well, we're only doing 20 megahertz wide channel bonding. The device is 2x2 MIMO, but you told me that the device, these access points will do 3.46 gigabits per second. It's like, yes, but the correlation between fact and fiction is pointed out here as well, which is really, really cool. Again, now this one is a great one. So I actually recently did my troubleshooting course, Ekahau course as well, and I've taken a couple of key points away from that as well, which I wanted to share with you guys today and just liven up my best practices as well, and information that I wanted to share with everyone today. So modulation for the devices, our signal to noise ratio, noise itself, and our received signal strength indication are all very important factors to be taken into consideration when, again, a customer may come to you and go, hey, Nath, what the hell? You sold me this solution. I can't get the speeds that you told me that you were going to get. Of course, I would never actually position something based on bandwidth or throughput. I would be designing a proper solution. However, customers, of course, sometimes will latch onto one key point and go, well, no, you didn't sell me, you sold me this, and it's not achieving it. This, again, gives you a great breakdown in a simple format to understand the requirements to hit those crazy speeds. This hasn't even taken into consideration what we have with 802.11ax, which is 1024 QAM, or quadrature amplitude modulation. And that is the modulation method that's being used here. So, what do I mean by that? If 1024 QAM's up here, well, yeah, you need a stupidly good signal. So you need to be, right now in my office, my Fortinet FAP U431F, one of their beastly, awesome universal high definition, or high density, I should say, access points is about 2 meters away from me on a tripod. I'm in a rental, so I can't exactly mount to the roof or the ceiling like I would like to. But that being said, of course, my signal strength is fantastic. So I could probably, this is a Wi-Fi 6 laptop, I could probably hit 1024 QAM in terms of that modulation and hit even faster speeds. But as we see here in this simple breakdown, a customer might come to you, and you might be working with a customer that, oh, I'm not hitting the speeds that I'm supposed to. Okay, well, what exactly is going on with the signal? How far away are they from the access point? What's their received signal strength indicator? And based on that received signal strength indicator, every time it goes down past a threshold, as we can see here, it actually drops the modulation. What does that mean? If we have slower modulation, we have slower bandwidth. Therefore, the user experience may differ greatly. If they're right on the cusp of the range of the access point, and they're down into, neg 75, and then a little bit lower, getting into OFDM, QPSK, well, they're going to be connecting at quite a slow speed. Get close to the AP. And again, when we're looking at designing for specification, so what do I mean by that? Whether is it a data network? Is it a voice network? Do they need RTLS, real-time location services? Do they need to do high definition 4K streaming? All of these factors need to be taken in when we're planning and designing a network. And of course, when it comes to Wavelink as a distributor, we would also always ask these questions and try and get as much information out of the customer as we can so we can hit the variables required. Great example, our Spectralink Versity smartphones that we sell a lot into hospitals, aged care, retirement living, manufacturing, warehousing, etc. When we're designing for voice, we need no greater than neg 67 dBm. So then we're going to potentially hit 64 QAM or above as we get closer to the access points and a clearer signal as well. So taking this type of information into consideration can certainly help you understand why a customer might be experiencing slower speeds. Oh, the good old, oh, well, I sit next to the access point, it's really fast. I move away from it, it's really slow. It's like, well, yes, it's how Wi-Fi works. Ripples in a pond is a great simple analogy I love to use in terms of how the signal floats through the air. And of course, the problem with Wi-Fi, we can't see it, can we? When we're trying to diagnose an issue with like a layer 2 network, we have physical cables, we have switch ports, etc., etc. We can see things, we can tweak things physically. Can't do that with Wi-Fi. You can't see it, and that also means you cannot see the interferers, what's causing potential problems as well. So again, this really cool breakdown, and I hope that one was a good one for you as well. Leads on to this awesome little breakdown as well. So we've got tale of two charts. Low signal strength equals low signal to noise equals less complex modulation, because as we go down in the signal to noise and a low signal, it has to use less complex modulation to achieve sending and receiving data. But of course, that equals low speed. More airtime utilization though. So devices can speak more freely and more consistently. So you can actually potentially have more clients talking at a lower data rate though. So again, horses for courses, what's actually going to happen with the client and their expectations of how the Wi-Fi is going to work. Conversely, so strong signal strength, just like I said, I'm standing right next to one of 4 access points I have on in my room at the moment. I've got a fan pumping on me so I don't get a tan. But then, so higher signal strength equals a higher SNR, which is great. More bars equal good, yeah? Okay, cool. But then that also translates to we need higher and more complex modulation to achieve those higher theoretical maximum speeds. Higher speed equals less airtime utilization as well. So again, it comes back to different variables based on the maths and physics of the technology. And again, ripples in a pond, further away you move from the center of the source, the slower the experience is going to be for that user device. And that being said, is a great way to start a conversation with the customer to understand if they're jumping up, oh, the Wi-Fi you sold me is crap. Okay, but why? What was your expectation in the first place? And of course, everyone's going to say lightning fast, fastest thing in the world, never drop out, never have any issues. And again, based on the technology and its limitations, which is again based on the physics, is always tricky. So again, a breakdown like this can give you a better understanding exactly what might be going on or things to look for. Told you I had a big crazy graph to show you. It's on the next page as well, but basically I wanted to give you guys a bit of a breakdown because some of you may have seen these types of charts. Others will be like, oh, pretty colors. If you haven't, it's okay. I'm going to explain it to you, and I'm going to jump into the command line on my laptop and just show you something as well that you can utilize as a little test at home if you wanted to, or in your office, wherever you want to actually try and understand what the hell all these numbers mean. But effectively what we're looking at is the modulation technique, the coding scheme, channel width, as we've discussed as well. Very important, the guard interval, either side of that channel, spatial streams, and the transmit power. So, yeah, I told you it was a doozy. That's a lot of numbers, Nathan. What the hell does all of this mean? So, as we've been discussing, the breakdown of your channel assignment, your channel width, how close you are to an access point, etc., can then lead to, of course, what modulation you are getting, and that will then translate to what potential speed you are getting. So I am doing 40 megahertz wide channel bonding, hopefully. And let me just quickly, I'm going to make my mouse cursor jumbo size. That was the whole point of my jumbo cursor. So people can see what I'm pointing at here. So I am currently in my network. I am doing 40 megahertz wide channel bonding. Then we should be able to cross-correlate information that I'm about to find in my command line as to where that relates to the potential speeds that I'm seeing, whether it'll be this end, whether it'll be that end. So give me a second. This is the first time I've done this on the fly, so let's give it a crack. So I'm just in command line. I have a Windows PC laptop. Obviously, if you're running a Mac, you've got some sick built-in features to do this Wi-Fi stuff anyway. But run command prompt as an administrator. Then it is a simple command of netsh. I wonder if I can zoom that in for you. Yes, a bit, lovely. So netsh space WLAN space show space interfaces. If I hit enter there, it's actually going to show me my chipset on my laptop right here, right now. Sweet as. How you doing? As we can see, Intel Wi-Fi 6, AX200, 660 megahertz capabilities. I'm connected to my SSID, which is my home 5Fi, stupid little SSID name that I came up with. I've got my BSSID MAC address as well. We can tell here radio type is 802.11ax or Wi-Fi 6 for the layman's. Then we also have WPA2 personal CCMP for the cipher. We're on channel 100, and we see receive rate in megabits and transmit rate. We also then have a signal strength of 97%. Again, I'm nice and close to my access point. So, again, like, Nate, okay, but what the hell does all this mean? As I was saying before, if we have a look at this, we can have a look at a rough view here. So I'm doing 2 spatial streams. So we're looking over this column here. We've got spatial streams, 2, 40 megahertz wide, and we're around 170 megabits a second. Hey, look at that. There's a simple breakdown of what the hell all these numbers mean. So again, what does that mean? What's the breakdown here? Well, I did actually mention before, because of my close proximity to my access point, I might even be hitting 1024 QAM, which at the moment is the highest level of modulation that we have in Wi-Fi, which is actually really, really cool. If I move away And, oh, Jesus, if I could do this in a cool way, but I can't, I'm attached, I'm doing a live demo. I need to have another device that I could remote into and put on a remote control car or something and drive it away, and we could just watch that modulation drop and drop and drop. Again, just to prove the point of what's going to happen, the further we get away from the access point, we are going to start seeing my receive signal strength and transmit rates drop down as soon as I get a little further away. Okay, I'll hit 256 quam, so different modulation. So, okay, based on that, then I might only be able to achieve 412 or 458 megabits per second, get away further. And we're at this line here, and I'm only achieving 275. Again, simple techniques and simple information that you can utilize if you are assisting a customer and scoping an opportunity, and with their greatest complaint at the moment that you're trying to fix, their pain point is, well, the Wi-Fi is really slow. Okay, cool. Where are you positioned and where are you sitting in the office or your work environment when you've got slow speeds? I'm in that corner. Okay, where's the access point? I think you know what I'm getting at. Understanding those elements. Where's the access point positioned? Is it installed correctly is another great point. They are the center of a donut, and they should be mounted horizontally on ceilings as well, not vertically on walls. And then utilize a tool like this, just a very simple command in command prompt. If you're a Windows user, again, you can utilize other things. It gives you a great way to understand potential speed and connectivity for your clients, and then get a better understanding or have them understand, okay, cool. Well, you're only doing 20 megahertz wide. Well, you're not doing channel bonding. I should premise that. You're 20 megahertz wide. Yes, you're doing the fastest modulation possible on 802.11ax, but this is the speed. That is where it's going to tap out. Again, if they were doing a little bit faster, sorry, doing additional channel bonding, 40 meg, 80 meg, 160 meg wide, etc., etc. So again, complex diagram, hard to understand if you don't know what you're looking for, and I really hope I've explained that in a way that was useful for you to understand, again, based on looking at this simple information here, cross-correlating it with this and going, okay, well, this is the speed that you should be able to achieve based on, as I am, being 2 meters away from my access point and getting a tan. So yeah, good stuff. There is another command in here as well. It's the same thing, netsh space WLAN space show, then all, and it will give you a hell of a lot of information. That's actually capturing everything in the air at a given moment and reporting it in for you. So again, very, very useful information there. Touched on this before. Simple way to understand if you've potentially got a problem. Well, you might be hard pressed to find your problem in that rabbit warren. But again, understanding that a Wi-Fi network is only as good as the infrastructure it's connecting to. You could buy the latest and greatest, fastest access points, 2.5 gig uplink ports, maybe a 5 gig uplink port, 8x8 MIMO, crazy throughput capabilities for clients connecting to it. But again, as I said, if you're connecting to a 1 gig switch port, and then you've got 1 gig uplinks from your access layer, your distribution to your core, and the switches are old as, the firmware hasn't been upgraded, there's just a myriad of problems, well, the customer experience isn't going to be what they expected when it's actually sold as well. So again, understanding that every other part of the OSI layer underneath the APs, and effectively access points are layer 2, making sure that your cabling is up to scratch, switch ports, switches themselves, internet connection, firewall policies, etc., proxies, all of that needs to be put into consideration when designing, planning, and implementing the world's best Wi-Fi. So again, just another simple analogy I love to utilize. Again, taking into planning, and we're going to jump into Ekahau shortly as well, but having a look at the structures, the physical structure of buildings, very, very important, because of course there is a major difference between a plaster wall and a brick wall, or a bluestone or concrete. Understanding the layout, doors open, doors closed, best place to mount, high density areas and requirement as well. Very important details. And again, when we do planning, we take all of this into consideration as well. Free path loss. So ripples in a pond. This is a proper image of it and how it actually works. So effectively, for every time you double the distance, you're losing double the power effectively. So yeah, it gets really tricky really fast in terms of planning. And again, that's where we have customers' interpretation of how the Wi-Fi is going to work, and then it's installed, or they install it, they didn't put it in the position, the access point of the position that it was recommended, or they install it and then they install a new wall in a building, like a feature wall or something like that. And oh, it's going to certainly impact that signal as well. And as we can see here, I, with my very close proximity to my access point, of course, am seeing great signal strength here. But again, as I've said, throw a wall into the mix, it's going to change the attenuation and the loss of that signal as well. So you're actually going to be, of course, a lot worse, or potentially worse off the other side of that wall as well. A couple of, but just some simple ones to take into consideration when planning or scoping opportunities as well. Again, you know, reflection, absorption, how much brick, concrete, dense walls are not Wi-Fi's friends. Yeah, free path loss, attenuation or loss as well. Not always a bad thing though as well. We can tune our access points down to facilitate more APs in a given area, to facilitate more clients, high density solutions. And all of this comes back to the most important thing. When planning planning a customer solution, what do we need to consider the most? And there's something that a lot of the time is overlooked. We need to plan for the least capable, most important device. What do I mean by that? Well, if the CEO of the business has a legacy device that connects at a slow data rate, but he or she is adamant they don't want to give it up because they really like this particular device, but it connects at 802.11b, which can bring down the network speeds entirely. Well, that's the least capable, but most important, because it's the CEO of the company. And if they don't want to give it up, well, you've certainly got to try and convince them. But again, that's where planning and correct planning, best practices come into play. Understanding the coverage requirements, secondary coverage requirements, especially when we need to utilize something for voice as a great example. So voice over Wi-Fi, RTLS, etc. Signal to noise, data rates, density and capacity. Density and capacity, especially when it comes to schools, hospitals, university campuses, TAFEs, anywhere there's going to be a lot of stadiums, another great example. Somewhere where there's a lot of devices in a tight area that are all going to want fast access as well, comes into that requirement quadrant. But again, planning for the least capable, most important device has to be a major consideration as well. That being said, let me quickly jump out of that. I'm going to give me a second. I'm going to fire up Ekahau just quickly and take you through the differences between a data network and a voice over Wi-Fi network, and the simple requirements for those as well, and what are the differences, how is it going to impact on that as well. Oh goodness, open that, whoops. Close that. Let's just wait for Ekahau to open, everybody. All right, so that is the data network. So now some of you that have been to my previous sessions may have seen this design before. It's a great and I utilize this one, it's just a great, simple example of the differences between a voice grade and a data grade solution. So I'm opening up the voice grade one now. So this one is an existing customer solution. They wanted to utilize Spectralink Wi-Fi handsets, but then we needed to see where their APs were. So we've done an audit of the existing solution, and as we can see here, we have a lot of areas. If we're hitting our threshold of neg 67 dBm, which is very important for voice, not only on the primary or primary signal, but also the secondary signal, we need to make sure we're hitting that variable basically everywhere across this network. So as I can see here, the client devices, as in a voice over Wi-Fi device, they'll see on the primary and secondary rate the APs in the corridors, but as soon as they get into the rooms, if they needed to roam, they're not going to know where to roam properly because of that low signal. So the original design was 31 access points. The replacement or intended design change went up to 79 access points, so more than double. And again, you might be like, oh, geez, it's a fair increase. Well, again, when it comes to correct planning and best practices, that is what is required. If you're actually trying to hit the variables correctly, and again, we always design for best practice. There's a lot of potential operators out there that would come in and go, oh no, you don't need that many access points. Secondary signal is not important for voice over Wi-Fi. Well, it is actually, and you need to be hitting those variables correctly as well. But one of the other most important things here that I wanted to highlight again is the signal strength in these rooms or lack thereof. What I might do, I'm going to select all APs and I'm going to just do a quick demo, disable selected APs. Okay, I'm going to turn on, where's one? Opposing ends of the building. We'll get them turned on, let's go. 2.4 gig and 2.4 gig. So, I was telling you before, on the right frequency, the access points will hear each other at low data rates and cause interference for each other. So if I change this one, I'm going to do a quick edit here and we'll go, what was the other one? Channel 11, wasn't it? I'm going to set that as channel 11 as well. So what I've got here is my, and the map looks very clean at the moment because of the area tool that we've got on, and that cleans it up. I'm going to delete that just to give you a better indication. See how now that I've taken out the area tool, see that interferers there? So the signal in that area is at neg 81. But at neg 81, they can still hear each other. And if they're on the same channel, could be causing interference for each other, and not allowing free path, for the client devices to speak in a more free and available manner. So these are the considerations that we need to take into account when we are doing proper Wi-Fi design as well. So again, co-channel interference and managing a design and a solution can be tricky. That being said, so Ekahau now as a program, you can actually, let me just go Control Z, 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 Z. You can actually utilize it when doing planning, and it'll actually turn off unnecessary 2.4 gigahertz radios. Again, you might be like, well, Nathan, why is that important? Again, as we've discussed, we've only got 3 usable channels, right, on 1611 that we should use. And if I generate a plan now, that, of course, won't create my plan properly. Thanks, mate. Give me a second. Let me change the APs, and then I'll redo that for you as well. Bang. All right, generate plan. We're going to turn off, disable unnecessary radios. What this is going to do is actually turn off the radios that are going to interfere with each other in the planning software itself. So again, quite useful. So we've got one here. That being said, if I pumped out a report for this, the customer, oh, why is there no 2.4 gigahertz coverage in this area? It's like, well, it's been turned off by design. Again, the additional signal facilitated by the fact that 2.4 gigahertz goes further will ensure that the clients will still be able to connect. But most of the time, you would be trying to push clients to 5 gigahertz. You might also be looking at this for the first time and go, okay, Nathan, how the hell does this actually make the planning accurate? Well, all of these walls, and you just saw, they're all live elements, right? We have to painstakingly draw them on unless we get a CAD diagram and it will auto-populate the walls for us, but we still have to go through and choose them. That being said, every wall that's drawn on has an attenuation value and we'll drop the signal to that point. I'll show you a fun example of just how much you can drop the signal. Let's change them all to elevator shafts and no one's getting Wi-Fi then. What? So select, oh yep, hang on, cursor. Change wall type and we're gonna go elevator shafts. Oh, what are I choose? Not quite an elevator. Want something very thin. Yeah, 2 dB. Let's go 30 dB. And no one gets Wi-Fi. So again, this type of program that we utilize for our partners when doing FortiNet solutions, we utilize to do accurate bills of materials to position the best solution for the customer based on their requirements. Again, this was a data network. I turned it into a voice network, added a lot more overhead. Of course, looking at that, okay, we needed more cabling, more APs, more switch ports. So again, it's always better to do the correct planning in the first instance, not after the fact, because the customer, they might complain about the price now, but if you put it in and it doesn't hit the variables that they required, well, you're going to have to go back after the fact. And if it's a new build where plaster isn't up, it's a hell of a lot better time to be running cables than after the fact as well. So yeah, just a bit of a snapshot there. Okay, I've waffled on enough and I'm conscious of the time. We've got half an hour left, so that should be enough time for me to hopefully whip through, get some configuration done on FortiGate and FortiLAN Cloud, the new iteration of FortiCloud Wi-Fi. All right, so I have FortiGate 60E DSL in my home network. I've got a 108E PoE switch. I've got my FAP 431F. I've got a U321EV, and I've got 2 S321C FortiNet access points. So let me go back to our dashboard. So of course, I'm also running FortiOS 7, I think 7.0.01. Awesome. So I've thrown on a couple of different widgets on the main page to have a look at, AP status, signal strength, interfering, SSIDs, etc., all useful and important information. And before I do any config, I might plug in with Ethernet, just in case. Wi-Fi is excellent, but nothing beats a cable. Right. Give me a second. Plug you in. Oh. Man, it's like a sauna in my office. All right, let's rock and roll. So, okay, just relog in now that it's kicked me out. Password, that's the right one. Okay, so that cursor's freaking me out. Give me a second, guys. I'm just going to reduce the size of it. Still pink. I'll be able to see it. All right, so configuration of 40 APs and 40 switch. Now, 40 Wi-Fi or FortiGate Wi-Fi. So the Wi-Fi enabled ones, this one is. So a 40 Wi-Fi 60E or a FortiGate. All FortiGate models have a built-in Wi-Fi controller. It has come leaps and bounds over the last few years, very capable in terms of the older wireless LAN controllers becoming a sunset product. So we have the capability under our our Wi-Fi and switch controller. Again, if you've seen this, if you've done this, fantastic. We may have people that haven't done it at all, so I'm just going to take it step by step, and we're going to run through it. Out of the box, and when you plug in an access point into, well, if it was PoE, into the back of a FortiGate directly or through a switch, obviously a layer 2 switch will just go straight through. If it's just passing the traffic, no VLAN tagging or trunking or anything like that. If it's just a flat, open, unmanaged switch, it'll pass the traffic through. How do these access points get found by the FortiGate itself? Which AP am I getting? Yes, excellent. They will call out with CatWap protocol. So the access points will call out, say, yo, FortiGate, I'm here, let's play. They will then come in and sit here in the managed FortiAP area. From here, they actually need to be authorized. So of course, my 431F or my U431F is on authorized. It's pushing out my home Wi-Fi, ready to roll. I'm gonna authorize the U321EV, just one of my old lady training points that I've got here with me as well. And then I've got a couple of the older S-series APs, what's going on there, to utilize in FortiCloud. Bang, let's go, rock and roll. Oh, look at that, it's online already, fantastic. Okay, so first protocol, authorizing your access point. Now, some people might think, well, would you create your profile first? Yeah, you can do that as well. You need to, effectively, there's 3 elements here that we need to configure. Authorize the access point, configure a AP profile for that specific model as well. It has to be for that specific model. And then an SSID. Obviously, I've already got some SSID set up, and we'll probably just tag those, and then I'll go through and create some others when we do some VLAN assignment as well. So, out of the box, once the FortiGate finds the access point with the CatWap protocol, it will be found here, and it will be under a default profile. Now, the tricky part with the default profile, hopefully someone sees it at the top, 4th line, 5th line, country and region. What did I talk about before? We need to make sure the access points are configured, and anything to do with the Wi-Fi is configured for the right regulatory domain. The ACMA, of course, Australia's regulatory body. You've got to ensure that you have it configured. So, as I said, profile, I'm going to have to create a new one because I can't actually edit the default and change the country code. I believe you could do it in the CLI, but I'm just going to create a new profile. Show you that method as well. So we're going to go FAPU 321EB -AU. So I know it's Australia. And then thankfully, with the new breakdown of these APs, they've actually itemized them, which is quite nice, into the Wi-Fi 5, Wi-Fi 6, etc., etc. Universal series here. So I need that particular one there. Country and region, specify Australia. Admin access, I'll throw in that and that just for the fun of it. Now, also take note, if for some reason you needed to facilitate connectivity for old legacy 802.11b clients, you need to come in here and select that as well. By default, it is turned off because, let's face it, no one should be using 802.11b. It's the devil. So I'm going to utilize N and G. This is a Wi-Fi 5 AP. Down below we have our 5 gigahertz as well. What did we say before about our channel assignment? 1, 6, or 11. I'm going to hard code it to go to 11 because based on my spectrum analyzer on 2.4. Hey, okay, there's someone transmitting up there. Oh, there's a couple up there. Let's go with, it's got cross correlation. Yeah, it's a bit of a pain. I'm going to go 6. Now, the auto slide is a bit of a pain as well. This one is a lot, so the percentage don't use that. Use DBM or auto. You can just set it and go like 23 DBM if you wanted to, as an example, or use the slider here as well. Is a lot better than the percentages. We're going to manually select our SSIDs, and I'm going to go my 2.4 gig SSID. Yes, I do recommend breaking out the SSIDs to be a 2.4 gig and a 5 gig as a separate. That way you can connect your 5 gig clients onto that dedicated channel or band and make sure that they're going to always be connected at that higher potential speeds. All right, 5 gigahertz. Again, we've got the capability. We could just do A, C, and N if we wanted to exclude A. We could do some channel bonding if we wanted to, etc., etc. We saw on the spectrum analyzer before, the top channels were pretty free and ready to roll. So I'm going to just select this one. Feature upgrade would be awesome for deselect all, select all or deselect all. DVM, I'm going to set that. I'm going to go to the slider there as well, and manual. And I'm going to select my other SSID. Click OK. SSID is already set up, but I will create one shortly. So we'll go through that and we'll see that. So don't stress there. Now, the next most important thing that we need to do is come back here and we edit our AP and assign our SSIDs. Manual, 5 gigahertz. Freaking awesome. So it works. So we've got now 2 access points pushing out the SSIDs. Obviously, I'm not going to see a differentiator between the actual APs, but I can certainly see clients on my existing home device, and away we go. So out of the box, that's it. We're done. We're good. We're ready to roll. You could connect, get onto Wi-Fi, and away you go. So yes, it is that simple. Very nice interface, quite easy to understand. We have a look at our breakdown of our Wi-Fi clients. So again, under our dashboards, I've added another widget here so we can have a look at our Wi-Fi clients, understand who's slamming the most data. That's my laptop, obviously, at the moment, because I'm hosting this session. Breakdown of the technologies as well. So yeah, it gives you a great insight there. That being said, there's instances and requirements for more involved configurations. So I actually have FortiLink set up on my switch, my Forti switch. So FortiLink is tagged on my interface 1 on my FortiGate. Of course, that utilizes default VLANs as well. So if we have a look at our VLAN assignment here, VLAN 1 is utilized for the tagging of FortiLink itself. So I'm going to now set up another SSID or another interface, but with a different, with a VLAN tagging or VLAN assignment, and also different IP address. So my default IP range at the moment is 192.168.5.0 network, and I'm going to create a new one, and we're going to throw it onto. We'll go guest. VLAN. We'll tag it to FortiLink, so it's actually passed through. We're going to go VLAN tag of 10. I'm going to give it a pretty color so I can see it and differentiate it easily. We are then going to go through and I'm going to set up my IP 172.16.10.1/24. We'll do HTTPS, we'll do security fabric tie-in as well. I'm going to set a very simple IP range here. Bang, bang, bang. Okay there. Sweet. I'm like, oh, mate, where'd that interface go? It's under the switches. Under Wi-Fi and switch controller, we have a look at our VLANs. We have it right here. Excellent. Now, we also, one of the key points here is need to make sure we're tagging it under our allowed VLANs. Select your little Dropbox. This is a little fun one, tidbit. I was working through the config and having a play with this and working with my colleague Panduka, one of our senior Fortinet gurus, in-house Fortinet gurus, and he's like, yeah, just right-click and assign the VLAN. I'm like, what are you talking about? What right-click? I was missing the little element. It's like, Nathan, you're an absolute goose. But it's always fun to laugh at yourself. So select your VLAN that you want to assign there as well. I'm going to go yes. Bang. Awesome. Good stuff. Yep. Cool. Then going to create a new SSID. It's going to be a bridged SSID. So this is going to be just Wi-Fi. Bridge. Nathan, yes. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8. I'm keeping a PSK on there. Don't want my neighbors jumping on my network. Security first, right? And we're going to click OK. Bang, bang. Now, of course, importantly, we need to actually assign that SSID to our access point. So we are going to come in here. Select that. I'm going to put it on 2.4. I just want the Wi-Fi, the guest clients to connect on 2.4 gigahertz. Fantastic. Cool. Now, in theory, that should be being pushed out. Come on, baby. Wait, hang on. What else did I need to do? Do need to also create a firewall policy to make sure that traffic's going down. God, I don't know who created that, but righto. Give me a second. Let me also create the firewall policy. Man, it is hot in my office. What do we got? Guest. Access. Guest. Going. DSL. I'm just going to go all in all for source, destination, and service. You could obviously, if this is a guest SSID and access, you'd probably just select HTTP and HTTPS. For this demo, I'm just going to go all of it, and there we go. All right, let's make sure that that is getting pushed out. Yep. Let's go to you. Make sure you're pushing that out. Excellent. There we go. All right, cool. Bang, under the AP profile. Come on, baby. Just wait for that to come up. Actually, I'll assign it to my in-house one as well. Oh wait, actually, wrong radio. All right, Nathan guessed. Now let me do a quick CMD, IP config. Cool. Am I connected via the Wi-Fi's? I am at the moment. Yep, I'm on the 5 network, right? Okay. Now, as long as I did this correctly. Connected. Yeah, let me disconnect from the other one. So the gateway was correct. I've done something incorrect. So it's got the right gateway with an IP mismatch. So let me disconnect. I'm going to disconnect from the other network. Well, we'll connect again. Fingers crossed we get the right IP. Hey, got the right gateway though. Connected. Come on, baby. Hey, no, it's still being a dude. Still being stupid. Let's go. I don't want to clear my IPs at the moment because I don't want to get kicked off. But that method itself, let me try and connect one of my test handsets. I've got a heap of Spectral Universities here with me as well. Hey, okay, cool. We've got clients connected. Oh my goodness, it is really warm in my office. Nathan Guest, fantastic, cool. So, still, I've stuffed something up with the IP address assignment. Let me check that quickly. Interfaces, actually no, it'll be under VLAN. See, how good are live demos? What have I misconfigured? I'm conscious of the time here as well, so I don't want to harp on trying to troubleshoot that. But again, we had the right gateway. I've misconfigured something somewhere. We have connectivity though, so that's a winner. And we'll move on. So again, I just wanted to run you through this configuration and again, show you the simplicity of setting this up on the gate and how useful it is. Obviously, given the power of a FortiGate, best next generation firewall in the market, the fact that it has a Wi-Fi controller built in, outstandingly cool. Right, let's quickly move over to FortiLAN Cloud. Now I've got to, so FortiLAN Cloud itself, again, super versatile in its capabilities. The console that we're seeing here is the management console. So out of the box right now, licensing and the modeling has changed a little bit. You get free instances. And instances, I mean by sites, effectively. So think of those as logical sites, logical destinations, offices, etc., etc. This is where you can view and manage all of those. So Wavelink is an example. We have an office in Melbourne and Sydney. So we could have our Melbourne and Sydney office hosted in here and utilize that. Then configure individual instances for that itself. So then if I click on FortiCloud AP demo, it'll actually open up that instance of that Wi-Fi network. This instance is where all the configuration is done. Configuration, then you've got a hell of a lot of monitoring tools, etc., reporting, logging, switch management as well has been brought in to FortiLAN Cloud. So again, very, very cool in its capabilities. What I'm going to do now is run you through, again, just a very simple configuration requirements for FortiLAN Cloud. Out of the box, and as we can see here, I actually came in the other day, deleted everything. Out of the box, when you click on configure, you have obviously quite a lot of options here. You've got your SSIDs, you've got your platform profiles, BLE profiles, etc., QoS profiles. You can come in and do that configuration. So I'm going to go for FortiWiFi, Wi-Fi demo. I'm going to just use WPA again. Obviously, you've also got mesh link capabilities that could be configured in here. I'm going to go the old faithful 1, 2, 3, 4, 5, 6, 7, 8. We're not going to put a captive portal on just now, but you've got the capability. It's actually built in. You can utilize captive portal in FortiLAN Cloud. Again, really useful and versatile for customers, cafes, any type of business that wanted to have a landing page and or authorization for those clients to actually get onto the Wi-Fi. Advanced settings, this comes with the advanced feature license. So if you did need to tweak it and you were looking at utilizing FortiLAN Cloud for a voice grade solution as a great example, this is where that licensing comes into play. One of the major reasons, K and V standards, 802.11k and V are utilized for fast handover for voice clients in the network as well. So Also allows you actually to trim data rates, which of course can be very useful. Next, security features are all built in. Very, very cool. Antivirus, intrusion prevention, blocking botnet, access control for the Wi-Fi. I'm just going to monitor everything. We could do application control as well. We could set up when it's actually available, availability. So again, same thing. If it was a site that was providing guest access, but they weren't a 24/7 operation, they don't want people accessing the Wi-Fi after hours, you've got the capability of setting up a schedule for when that can be utilized, as well as Max clients for the radios. So I'm going to click apply there. It just gives you a review of exactly what you're setting up. Now I'm going to create, I've already got a profile in there, look at that, one I prepared earlier. Same thing though, just like the FortiGate, we actually have to create a profile that's specific to that access point. Same thing here, we have a great breakdown now of all the APs and the different guises. Of course, once again, guys, country code, very, very important. But you would go through here and actually tweak and configure exactly what you need for this AP profile and what you're going to push out for that AP profile as well. So I've already got one. I'm just going to utilize that for the moment. Now deploy some APs. Which are my APs? 086. Yes, lovely. And 165. Bang. All right, cool. Now, don't worry about the expired license. We used to use these for training and demos a couple of years ago, and we haven't upgraded the license, so it has expired. I'll still be able to utilize them though. That then, so you've selected your APs, and on each access point themselves, and the switches and the gates, they have their FortiCloud key. That is how we can utilize that. So if we wanted to add APs, we'd actually find the FortiAP key that's on the access point or the switch or the gate. We're utilizing Fortinet's cloud services. Put that in there. Obviously, you can do a bulk upload as well, but I've already got my APs in there ready to rock and roll. Select next. So it's already picking up my platform profile that it was created as well. We know it's for AU, so we know it's good to go for our regulatory domain, which is excellent. I'm going to leave all that there. We don't need to really specify anything else. It will just automatically pick up that information. I might just go some little tweaks. Why not? Bang, 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 and automatic, and we'll crank it up. And the U will crank down because we don't want too much 2.4 gig. All right, now site as well. So this ties actually back to the physical location of the site. I've got it set to our Wavelink office at 318 Auburn Road, Hawthorne, and you could then actually view the APs on a map as well. I'm not going to, actually, I'll just do admin. 1, 2, 3. Fantastic. Yes, deploy. Yes, please. That's just griping about the license. It will still work fine, even though it has expired though, which is good. Yes. Refresh. Now, in theory, I should have a couple of access points online and working. Oh, they're still offline for the moment. Of course, they're making a fool out of me. It's okay though. They should be coming along online shortly. Since they've been deployed into my network. But when I looked in here previously, I had one legacy one, the 993. Any Porsche fans out there? 993 is sitting in there. It was the only one actually in there. Now that I have put in the additional APs, champions, let's go. They should be there. Yeah, they've been deployed. I'm just waiting for them to come online now. While I wait for those to come online, again, 5 minutes left. I know we're running out of time here. What I did want to just cover off, though, again, in terms of simplicity. So if we were looking at this holistically and we wanted to come in here and let's delete that. So you've got a new customer engagement, installation, etc. You could come in. Oh, sweet. Thank goodness. One's come online. One is online. Again, this is the command dashboard where we can see our multiple sites. Again, as I said, out of the box, you get 3 sites that you could manage and set up individual instances. But we could just add another network. So same thing. Wavelink, Sydney. Find your time zone. Bang. Where are we? Sydney, Sydney, Sydney. Can't see for looking. That'll do. Melbourne's occasionally cooler. Anyway, that though, as we can see, I've created a new network instance, just like I clicked on the FortiAP Cloud. We've then clicked on that, and of course, it opened up the network. If I go to the network, this is where we get the more granular and detailed view of exactly what we are managing, client connectivity, all of that sort of stuff. We know that our access points are connected here. Let me get some devices connected to it, and I will get some traffic running through as well. What was it? 40 demo. 1, 2, 3, 4, 5, 6, 7, 8. Connect, please. And thank you. Okay, clients. We got one. Excellent. So that's my SpectraLink Versity handset that I've got on there. At the moment, let me just go onto YouTube, go to Linus Tech Tips. I'll just get something streaming quickly so we've got some data flowing. But as you can see, guys, I started this demo, I think at like what, 12:46-ish. I've already got a network set up and working, right? It sort of, it's my brother, great. I have a network working, up and running. The simplicity and capability of this product set is bloody awesome. We can then, of course, monitor everything that's going on in the network, rogue clients, client devices, throughput, other capabilities, the radios themselves. Yeah, really powerful, great product. One of the kickers as well at the moment, if you didn't actually know, I said before, you can utilize 3 sites, so 3 logical locations, offices, whatever, for your business, or if a customer's got 3 locations. Cool. Buy the access points, deploy the APs based under the inventory that they've purchased. Out of the box, it's free. Unlike your Cisco Meraki's, your Extreme Networks, think of any other subscription-based, HP Aruba, another great one, as an example. It's pay to play. This out of the box at the moment, just with the base features, so 7-day log retention, obviously enough to set up a fully fledged working network. Again, if you did need it for voice, I would recommend utilizing the additional licensing capabilities. So you've got your advanced feature sets, but if you don't need it, you just need a good data network with high-speed connectivity, video, etc. This is an amazing product, easy to deploy, or easy to configure, deploy, manage, etc. Reporting capabilities as well for management. And of course, well, you can also throw your 40 switches in there as well. That caps us off nicely, just a few seconds before 1 o'clock. So let me jump back to there. And I want to see if we got any questions, feedback, analysis of my fast-paced delivery. Any questions? Throw them into the chat box or the question box if you like. More than happy to answer any of them. Oh, we do have some. Lost connection. No, I find attach the SSID in the profile IP beneficial rather than. Yeah, thanks, Panduga. Cheers, mate. So Panduga had some feedback there. So attaching, if we go back to my gate, and I did this previously, and it was a bit of a misstep by myself actually, and it's something that I don't do. And I'll just quickly show you. Admin. So assignment of profiles or assigning your SSID to a profile really should be done in the AP profile. I did it under the managed, and you might have seen it didn't quite work properly. I did an edit here, and then I assigned it, but then it wasn't actually showing the SSID. Best way to do it to make sure it's going to work properly, and we saw that work properly after the fact, and I changed it as well, was assigning the SSID into the profile itself. So again, finding your right SSID and assignment there. Stephen Allen, my man, know that your sample SSID design that you are using a default power level 6. Yes. Yep, there are a few different schools throughout on the topic. I was wondering. Awesome, Stephen. Great question. So, Stephen has asked the question around when I'm utilizing Ekahau design. When we are doing planning, we always utilize. Let me just quickly. I'll just quickly try and find a file to open up for you that I can share with you. Multi-story design. So whenever we do planning, as in Wavelink, myself, my team, when we're doing Ekahau designs, we will always utilize the base output power on the access points. What does that mean? What do I mean? In Ekahau, the base output power is 25 milliwatt. We design our networks at 25 milliwatt to ensure that we are understanding how the network is going to perform at low power. We could chop and change the access points themselves. I'll show you here. We have 25 milliwatt, which equates to 20.49 dBm and 6.3 or 12.5 dBm with the conversions. So best practice is effectively to do planning at low power. You can change the variables here, and what I'll show you, what I'm going to do, I'm going to disable this access point here. Action, disable him, and we'll disable him. This little one here. Now, one of the key and most important things with Wi-Fi design and planning is actually coverage. Can be overlooked, but coverage is king. So if this AP goes down, but that one was on, would it be able to facilitate a better signal? And yes, you're going to have something better there. Now, there's a different variable that we can look at there as well. So we can also then look at, okay, cool. So, well, then why don't we just crank the power? Because a lot of sites will do that. And, you know, out of the box, the APs themselves are usually programmed to be a lot higher than 25 milliwatt. So that in itself makes it trickier. So, of course, as you just saw, I'll just Control-Z that. You saw better signal facilitation in the middle there. If I go back the opposite way, we're filling in more signal because we've turned the power of the access point up. However, whenever we are planning, we usually plan for 25 milliwatt. What that enables us to do is facilitate more access points to ensure that there is more available APs for handoff. A lot of the time we're designing for voice as well. So a voice grade solution needs good handoff, secondary signal coverage. So if we were planning at a higher output power, then the secondary signal itself might not be facilitated as well. So yeah, we usually do 25 milliwatt. Let me just scroll back up. So Stephen, any tips? So Kevin as well, any tips for where we can get this sort of reference material online or on demand? Guys and girls, I am more than happy to share the stuff that I went through with you today. This is no secret source. I've taken a couple of slides, again, free and available information, so more than happy to share the slide deck, which is pretty simplistic, and we have recorded the session as well. So happy to send that out. Also, another area of truth and awesomeness, docs.fortinet.com is your friend. If you're looking for a configuration guide and a way to actually facilitate something, then yeah, docs.fortinet is definitely your friend there. Let me finish off the questions. What else have we got? So it was Kevin. Yep. Bang. Ray, Nathan, I saw when you did Ekahau site survey, you're using measured. Is this better following Ekahau offset recommendations, for example? Yeah, so same thing again, we'll use the Ekahau best practice. It aligns with the requirements for spectral diversity handsets. This is a great example. So between neg 65 and neg 67, dBm is sort of that threshold that we want to hit. And utilizing their best practice within Ekahau is an easy way to facilitate that. We also make sure that we are not adjusting the sliders, because in Ekahau, there's some easy ways to fudge the signaling and make it look super green and super awesome, even though it's not. So we always utilize, again, lower power and those thresholds to make sure that we are trying to design the networks as accurately as possible. Jensen, my man, what do we got? What are the benefits of FortiLAN Cloud versus FortiManager? Great question. I might take that one on notice to get back to you. I'll work with my FortiNet team. They are certainly more clued on with FortiManager, but effectively FortiManager is going to enable you to do large-scale management and deployment of the gates. FortiLAN Cloud, not same thing, but you've got the capability of utilizing FortiManager in the cloud as well. I don't know that it's as feature rich. Sometimes the crossover isn't as robust in terms of those feature capabilities. Kevin, any FortiLAN adoption and config for FortiLAN. Adoption for it. I'm actually probably one of the biggest advocates for it. I find the product really cool. It's come a hell of a long way since I started using it 4 years ago. And it's gotten to a point now, as I just showed you, simple, effective, great analytics, great data that you can see at a very simple snapshot to understand what's going on with the network. So it's come a hell of a long way. I quite like it. That being said, it's a product that is still probably one of the really good unknowns for Fortinet, unfortunately, and it just needs some more marketing and advertisement in the market to generate excitement, basically. Right. Yep, and back versus FortiWiFi. So FortiWiFi and cross-correlate there. So FortiWiFi versus FortiLAN Cloud. FortiWiFi is definitely being utilized way more than FortiLAN Cloud. A lot of the times it's a case of is there a gate at the front of the solution? If there is, well, you can utilize the FortiGate. However, based on the size of the gate equals limitations on the amount of access points that you can utilize. So that being said, depending on the size of the solution, FortiLAN Cloud could be a better option than managing it via the gate as well. Again, costs for the customer as well. What we got? Does FortiGate partner with any Wi-Fi analytics systems like Purple? Great question, mate. I'll take that one to look into as well. I know, like, Purple is a great example. They themselves, I think, do a lot of the integration. Don't know if there's anything specific at the moment, but I'll certainly take that one as an action to chase up. Stephen Allen, as you are advocating splitting out SSIDs for dedicated 2.4 and 5 gig, I gather you are not a fan of band steering. No, look, band steering has its place in the market, and if those that don't know what band steering is, band steering, effectively any client that joins the network, if you are pushing out a shared SSID facilitates both 2.4 and 5 gigahertz. Band steering will try and push the clients to 5 gigahertz to try and facilitate faster connectivity, better throughput, all that sort of stuff. But of course, again, smaller cell size, so it does have its not disadvantages, but you've just got to be aware of those things. Personally, certainly for home, yeah, I always split it out because I want the ability to choose myself, not have band steering on. Again, it can be useful and a good feature. It just depends on the network. That being said, obviously there is the overheads that we need to take into consideration for additional SSIDs. No more than 4 SSIDs max on a network, even if it's, you know, hospital, school, etc. Try and get all that data. So school's a great example. Staff and students, if they're utilizing like Radius or something like that, have them connect. You could put them onto one SSID if you wanted to, as long as it's all tagged in the back end, VLANing, domain controller, infrastructure, etc. ties in. Well, they're going to get access to it properly. Then have maybe one for guests, maybe one for events or something like that. So that being said, obviously it's a lot harder to do that. So you could have maybe a staff and student 2.4 and a 5 gig, or utilize band steering as well. Guests, band steering, go for it, who cares? We got, and then one more from Ray. Sorry, I mean this. Oh, okay. Oh, we've got, give me a second. I've just got to copy paste that, mate, and do the search. Okay, view modes of RSSI offset. What is that? Blah, 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 blah. Oh, cool. Right. So, yeah, I was looking. So the RSSI offset, generally when we're planning, we don't look at it as like a, what's it called in there? Like a mobile device. We usually do actually look at it as a holistic approach to the network. That being said, of course, if you are looking at that, and those, I might just quickly share my screen again for everyone that is still on, and appreciate that you've stayed on for the additional time. So when looking at the network, we can look at it in Ekahau as a generic device, or we've got the capabilities of looking at it from a mobile device point of view. Why is that important? Well, mobile devices have way smaller antennas. So yeah, that is why they built that feature into it. It's very useful. A lot of the time when we're doing our planning, we still hit our variables to make sure that that's going to be facilitated for that without actually needing to utilize the mobility device view as well. Awesome. All right. If no more questions, thank you so much for your time today. Obviously, a bit of a long session. Hopefully you got something out of it. I'm sure and hope you did. As always, feel free to email me any questions, give me a call. Always happy to have a chat about Wi-Fi. As we know, it's probably my favorite thing to do. So yeah, thank you all so very much for your time today. Always appreciate it, guys.